All right, so we're going to do section 3-4, new lesson. Again, like I said earlier, we'll probably take 2 days to do it, but that's okay. I put that on the lesson plans anyway. So, Sam, you said, what? What the heck is an inverse function? Okay, well, I'm glad you asked. So, you know what an inverse is. So, like if I ask you, what is the inverse of 2? Is it? It's 1 over 2. So if I said find the inverse of something, okay, of just a number, that's not exactly what an inverse function is, but it has a little bit to do with it, okay? So it's an inverse. Like if I said 2/3, what's the inverse of 2/3? It's 3 over 2. Now they're not equal to each other, right? So I didn't put an equal sign, but those would be inverses of each other, okay? There's other things, and we're going to talk about a lot of other things today. So for instance, like if I gave you, and we will do this one, what if I gave you y equals 2x plus 1? Now that's a lot different than just giving you a number and then just flipping it. I'm not just going to take this and put it over 1 or under 1. Okay, I'm not going to just go 1 over this. There's a little trick. There's a little formula, a kind of formula, okay, a way to do this, we'll say, to find the inverse of that function. But that's what we're doing. We're finding the inverse of this. Let me show you a notation for inverse. So we have notations for lots of stuff in math. So if your function is f of x, that's your, I'll just put a little arrow there. That's your function, right? We've been dealing with that quite a bit. So you should be pretty familiar with that, right? Pretty comfortable with f of x, would you agree? Yep. And you kind of know how to work with it. The inverse function, we write it like this. We write f to the negative first of x. It's just kind of what we did before. So if I said, what is 2 to the negative first? I'm just showing you why we use this as our notation. What does this mean, 2 to the negative first power? You did that in Algebra 2, didn't you? At least in Algebra 2. You might have done it in Algebra 1. I don't know. Nobody's seen that before? A negative exponent? You've dealt with negative exponents. Surely you have. Don't call me Shirley, right? That's an old joke from a movie. Airplane. You ever see Airplane? Yeah. You got to watch it sometime. Ask your parents. I don't know. Your parents might even be too young to have watched Airplane. But the pilot says something like, surely this can't be happening or something like that. And the guy's like, and don't call me Shirley. But it's all dumb jokes like that. The whole entire movie is full of just like, it's hilarious though. It's absolutely hilarious. One of the funniest movies ever. Anyway, so 2 to the negative first. Nobody knows? Although you're dying to tell me. I know it. Come on. What do you...
1 over 2 to the first.
Yes, exactly. It's just 1 over 2 to the first, or just 1 over 2. So this notation right here means you just take the what? The inverse of it. So they brought it over to functions, okay? And they use the notation for functions. So what does this mean? This means the what? The inverse. That's what we've been talking about, right? It's the inverse function. All right, so we need to know the notation first before we can do anything. So if you're going to graph something, I wrote all this stuff down. I'm just going to say it and show it to you instead of write it all down. It'd just take too long if I wrote it all down. To graph an inverse relation or function, because sometimes this may not be what we're taking the inverse of, may not be a function to begin with. Remember the function test? To see if it's a function or not? What do we use? The what test? What is it?
Pencil test?
Pencil test? Vertical line test. Thank you very much. We use the vertical line test, all right, to determine if it's a function or not. We can still find the inverse of something that's not a function, but anyway, let's keep going. What do I want to do? Okay, so if we were to graph something like I wrote earlier, we're going to write f of x equals 2x plus 1. I just made this up. This is not in the book. All right, the example they gave in the book, I thought it was a little too soon to do that example. I wanted to make it a little bit easier before we get to the first example. So this is kind of like just my personal example. What I want to do is find the inverse of this or graph the inverse of it. So I'm going to show you how to graph the inverse of it first, and then I'm going to show you a little method. That's probably a better way, not a trick, but a little method to find the inverse of this particular function right there. There's algebra that we can do to find the inverse of this. But I want to show you graphically how it works out. So remember the old days when you first were graphing stuff? I'm going to put a y here, but y basically means the f of x. Everybody with me on that? You could just put y equals 2x plus 1. So what'd you do when you first learned how to graph stuff like this? Before you even learned about the y-intercept and the slope. You remember what you did? Put this little table, and then you just threw some points in here, didn't you? Right? Just put some random points in here. And we usually kind of stuck around 0, all right? So I'm going to do the same thing here. All right? We can do this in our head. Put a -2, and let's find our y, and let's graph it. We will graph this. Okay, so 2 times what? -2 is -4 plus 1 is -3. Put a -1 in here. -2 plus 1 is -1, right? Put a 0. It's just a 1. Put a 1 in there. 2 times 1. 2 plus 1 is 3. Put a 2 in there. 4 plus 1 is 5. Okay, everybody with me? And you could graph this. Yep, I'm going to do it right now. Might as well start here. It's a lot nicer if I have a little graph paper thing here. So let's pull this over and let's make it so I can see it. There we go. There we go. All right. All right, so let's graph this thing. Let's just do it in red. Again, we're doing it the old-fashioned way. I could go y-intercept, slope, easy, but I'm going to do it this way. -2, -3, -2, -3, 1, 2, 3, right there. -1, -1, 0, 1, 1, 3, 2, 5. Everybody with me on that? And then I just connect them, right? And let's make this go down like that. All right, so that's how we graph that function, right? Old school way, right? Pre-algebra, algebra 1, right? When you first started learning it. Then, even in algebra 1, you learned, hopefully, y-intercept and slope. Did you? Do you remember? I don't know. Can you remember back that far? All right, so now let's do this. Let's do the inverse, all right? So what you're going to do, kind of do the same thing, but the inverse is, you know how you found the inverse of a fraction? What do we do with the inverse of the fraction? We switch the top and the bottom, right? You remember that 2/3, 3/2, yes? Okay, so what do you think we're going to do with the x and y? I gave you a big hint. With a fraction, how do you find the inverse? Just switch them, right? With a function, how are you going to find the inverse? Just switch them. So instead of a -2 being here, where is it going to be? It's going to be right there. Everybody see that? And instead of a -3 being with the y, where's it going to be? With the x. That's how you find the inverse of a function. It's the basic way how to find the inverse of a function. All right? You just switch the x's and y's. That's how you find the inverse of a function. Okay? So let's write it out. So it's -3, -1, 1, 3, 5. See what I did? I just took all these y's and I stuck them in the x columns. Now what am I going to do? Take all the x's and put it in the y column. So what's that going to be? -1. That's going to be a 0. It's going to be a 1. It's going to be a 2. Now let's graph that. Do it in a different color and see what it looks like. And we're going to find something that we've talked about earlier. Okay, so a lot of the stuff we talked about earlier is going to come back. All right, so hopefully that'll be good for you, I guess. I don't know. So let's graph these. -3, -2. 1, 2, 3, 1, 2. Okay, -1, -1. Oops, it's right there where the other one was. So it does intersect right at that point right there. All right, and then 1, 0. And then 3, 1. 1, 2, 3, 1. And then 5, 2. Right there. And then we connect them. And like that. And that blue line is the what of the red line? It's the inverse of it. That's right. It's the inverse. So instead of this being 1, 3, what is it over here? 3, 1. Everybody see it? So see how that one and that one relate to each other? We just switch the x and the y. Here's something that's kind of interesting as well. This is what I talked about just a minute ago. What does it look like? It looks like they're symmetric, right? Symmetric over what? What line? Come on, we've talked about this. We've done this. What is that yellow line? Y equals x. Okay, so it's symmetric over the line y equals x. You see it? If I put the mirror where the yellow line is right there, if I put a mirror there, wouldn't that red one and that blue one show up in that mirror? Yep. One would be going this way. One would be going this way. Whoops. Right? And that's your mirror right there. So it's symmetric about the line y equals x. That's what an inverse does. So any graph you have, if you know some points on there, if you just switch the x and the y and you make another graph, right, just switching the x and the y's, that's your inverse. Does that make sense? Yeah, it's not too hard, is it? No, everybody can figure that out. Now, let me show you a way algebraic. Oh, let's do this. This is what I was going to do. This is kind of interesting. Let's find what the equation of that blue line actually is, what the inverse of that line is. Can you just use the graph and look at it? What do you think the y-axis or the y-intercept is of that blue line? I'll just move it over so you can see a little closer. Just take a guess. Yeah, it's half, okay? And then what's the slope? It's 1. Let's see. If I... Yeah, how do I get... I tell you what, let's just do 2 points that I know instead of doing the half thing. That was dumb. I don't know why I did that. Let's go from one point to another. It doesn't matter. I could go from here to here, couldn't I? So what is it? 1 over 2. Right. Okay. I don't have to do the half thing. All right. Because look, if I go over 1, I go over 2, I'm right at that half right there. So you could have done that. All right. But yeah, from here to here, it's 1 over 2. So what is the inverse? What's the equation, I guess you could say? What's the inverse of this? What did we say it was? What's the y-intercept? It's negative a half, right? Do you agree? And then what's the slope? It's positive 1 over 2. So it's y equals 1/2 x minus 1/2. You see that? How did we get that? We got it from the graph. Make sense? All right. I'm going to show you another way to get it, though, okay, without having to graph it. It's kind of a cool way. I haven't done this in like many, many years, probably since I taught at my old school, and I'm surprised that I actually remembered it. So what we're going to do, let me just take this. Now, there's what we want to get right there, but I'm going to show you how to get it. And it's kind of easy, really. It's really not that hard. If I can do it, shouldn't be that hard. So what I want to do is find the inverse of the function. Okay? So here's what they give you as the function. I want to find the inverse of the function. Now, if you really, really wanted to, I guess you could graph it and then look at the graph and figure out what that graph is. But man, if it went through like the y-axis at like 3/8 or something like that, there's no way you could guess that. So it's not very accurate doing it that way, but here's another way to do it. What we're going to do, I'm going to write it with a y instead of f of x. What I'm going to do is I'm going to solve for x. Solve for x. So let's do that first. So that's our first step. Put a 1 right there. Okay, so I'm going to solve for x. So let's do that. What's first step? Minus 1. So what's 2x equal to? Y minus 1. Agreed? Now what do we do? To get x by itself, I want to solve for x. Divide both sides by 2. Yes? Is it starting to look a little familiar to what we said it was going to be? But with a slight difference. So this is what? Y over 2, or 1/2 y minus 1/2. But is that our equation? No, because I went y equals something, correct? So what do you think our second step is going to be? How do I make this look like that with this being a y. Y equals. It's almost just like it, except for what? What's the only glaring difference? Yeah, the x and the y are switched, aren't they? So guess what we're going to do? To do an inverse, remember we did on the little table thing? What do we do with the x and y? Switch them, okay? Excuse me. So let's switch it. So we switch or exchange, or I don't know, whatever your word. Switch is fine, right? Switch the x and the y. All right, so what's this going to look like now? Y equals 1/2 what? X minus 1/2. Whoops. There we go. So that is the inverse of what we started with, which was right there. It's really not that hard. Again, what do? 2 steps. We take that function and we just make it y instead of f of x, okay? So we solve for x, not that big of a deal, just get x by itself. And then we just switch the x's and the y's. So instead of this being x, we make it a y. Instead of that being a y, we make it an x. No biggie. And then that's the inverse of the function. Is it what we thought it was going to be when we found the equation of that blue line? Yeah, it's exactly the same thing, isn't it? All right? So I think it's good to see where that came from. Okay, switching the x and the y's and solving for x and all that kind of stuff. It gives you what you thought you should have gotten. Does that make any sense? All right, because when we looked at the blue line, we looked at it and we said, okay, what's the equation of that? Well, there's the y-intercept. The slope is 1/2. Y-intercept is -1/2. Boom, that's the equation of my function, or my inverse function. And you're like, well, there's got to be a better way than having to graph it and then figure out what that graph is. So what do? You solve for x, and then you switch the x and the y, and it gives you the same exact thing. You guys don't look that impressed. I thought you would be a little more impressed with that. You don't like that? No? Oh my gosh. I'm all excited about this, and I'm getting all these blank stares. Is it because you don't understand what I'm doing, or is it just like not that impressive? Just not that impressive? That's fine. All right. Now, let's do the real example that they give you in the book. Okay, so that was like my made-up example because I needed something just a little bit easier than what they give you in the book, and I thought that was a good, easy example. We'll call that the pre-example. So here's example 1 in the book. And they ask you to graph it, and they ask you to graph the inverse. So graph this. F of x equals -1/2 absolute value of x plus 3. So they ask you to graph that, and they want you to graph its inverse. Okay? So, where do we start? Well, you could graph this, I guess. It's got an absolute value, so what kind of basic shape is it going to have to it? It's going to be a V, right? But it's got a negative out in front, so what does that negative do? Makes it flip, okay? So, I don't know. I can't do my hands that way, okay? It's like this. Yeah, there we go. So it's going to go like this. What's the 1/2 do to it? So does it make it wider? Does it make it skinnier? You'd think it'd make it skinnier because it's a half, but it doesn't. It makes it what? Makes it wider, okay? And then what does that plus 3 do to it? Moves it up 3, okay? So you could just graph it like that if you wanted to. That's perfectly fine. That's an okay way to do it. Or you could graph it like this with the table. Okay? They use these points. I think they're good points to use. Now, due to time, I'm not going to sit here and go through every single one and say, okay, what's the absolute value of this? What's half of this? What's plus 3 of that? I'm just going to list them, okay? But everybody can do that, right? I'll just put in a -3 in for this. Let's do the first one. That's all we'll do. So if I put a -3 in for x, what do I get? The absolute value of -3 is 3, And then 3 times negative a half is negative 3/2, right? And then plus 3, but it's over a denominator of 2. So what would that be? 6. So it's what? So it's 3/2. Yes? All right. If you didn't catch on, just write it down. You'll figure it out. So that would be 3/2. Or 3/2 is the same as what? 1.5. Or I'm going to write just 1.5. Is that all right? Now, do the same thing with all the other numbers, and I'm just going to write it down and see what we get. We get 2. We get 2.5. We get 3. Then it goes back down. We got 2.5. We've got 2. And we've got 1.5. Oops. I'm going to go way up here. Let's grab this one since it's already big. All right, let's go back down to this. And let's put our graph right there. So what does the problem say? Just graph that function to begin with, right? So let's put it in another color. Let's go blue again. So it's -3, 1.5. So -3, 1, 2, 3, 1.5 right there. And then -2, 2 is right there. Negative, is that right? -3. No, that's not -2, 2. What am I doing? -2, 2 is right there. That's why it's messing up. Okay, can't count. All right, and then what was the next one? -1. How far do we go? 2.5. It's right there. Go 0, 3. It's right there. Then it starts coming down. You understand why it starts coming down again? Because of that V shape to it. And then if I go 1, I go up 2.5. See, it's just mirror image of this one right here. And then you go 2, 2, right there. We go 3, 1.5, 1, 2, 3, 1.5. I could put more numbers in there, right? I could have gone to 4, 5, 6 and seen it go all the way down, but you know what it's going to do, don't you? It's going to do this. And it's going to do this. Agreed? All right. So now, what I'm going to do is I'm going to figure out what the inverse is. So that's the function itself. Now I'm going to do the inverse. So if I'm going to do it by this table, if I'm going to use this table to graph it, what do I want to do with the x's and the y's?
Switch them.
Thank you. I just thought that would be right off the tip of your tongue, but I guess not. All right, so let's switch them. All right, let's put the x's over here where the y's are supposed to be. So I'm going to go -3, -2, -1, 0, 1, 2, and 3. And then let's put the x's, or put the y's in where the x is going to be. So that's 2.5, that's 3, that's 2.5, that's 2, and that's 1.5. Okay? So now let's plot that. What color did we use before? It doesn't matter. I'll go yellow this time. All right, so let's plot this. If I go over 1.5, how far up do I go? Or I go down, actually, 3, don't I? 1, 2, 3. So there's 1 point right there. 2, -2. 1, 2, -2, right there. 2.5, -1. 3, 0. 2.5. This time we're jumping up to 1 this time. And then 2, 2. Right there, it intersects right there. And then 1.5 to 3 looks right there. So what does that do? Well, you should kind of know what it's going to do. It's still going to be a V, but what do? We kind of slanted it over, didn't we? So now this goes here, and this goes like that. You see it? So you got your blue one, which is your normal function, and the yellow one is the inverse of it. What did we say was true put this in red this time. What did we say was true about the function and its inverse? They're symmetric what? How? To the y equals x axis. So let's put the y equals x axis here. Right there. Is it a mirror image? It's not? Yeah, it's definitely a mirror image. Right? Because look, this one goes like this, slants like that, slants like that. That's a mirror image. How do you know? Because look, let's pick some points that were easy. What point was this one? That was 0, 3, right? So what's over here? 3, 0, right? And you keep doing it all along here. This was negative 2, 2, all right? And this is going to be what? 2, negative 2. See how they're mirror images of each other? Okay? They're directly across from that mirror. Think of that red one as being the mirror. All right? So those are inverses of each other. Now, that yellow one, that might be a little more difficult to look at the graph and figure out what the equation should be for that graph. It's actually, I don't know, we could just break it into two parts. Let's just do this part right here. Forget this part up here. Just do this one. How would you find the equation of this yellow part right here if it just went all the way up? Well, what's the y-intercept? Nobody playing along today? Is it 1, 2, 3, 4, 5, 6? Yep, so it's negative 6. What's the slope of this? I don't know. Let's go from here to here. So how far do we go? 6 over 3. What's the slope of that? 2 over 1, right. Okay. But this is not the same line, though, is it? So this would be what? It has a y-intercept of positive 6. And what's the slope of this line? Negative 2 over 1, or negative 2. So this part of it right there is y equals negative 2x plus 6. What's this part right here? Y equals 2x minus 6. Okay? We're not really going to write it as an absolute value. It's not really an absolute value graph. Okay? It's like a piecewise function, right? Piecewise graph. I think I can be safe in saying that. What if you didn't want to go through all that graphing to find the inverse of it? That's a pain in the butt. Would you agree? Yeah. So what we're going to do is we're going to take this and we're going to use that little method that I talked about earlier with the 1 and the 2. Remember that? All right, so let's find the inverse of this function. So I'm going to write find f negative 1 of x. That's what we're trying to find. But I'm going to do it algebraically. Okay, I'm not going to do it with the graphing. You remember what the first step was? What was the first step? No. In general, more general. Get x by itself. That's right. Solve for x. All right. So instead of writing f of x, I'm just going to write y equals. Now, you're going to have to know a couple of things about absolute value. I think we've talked about it earlier. We haven't harped on it a whole lot, but you'll see. So what do you think? I want to get x by itself. What's the first thing I want to get rid of if I'm going to solve for x? It's just basic algebra. Everybody try to pay attention and listen to what we do. What is it? Y? Is that? We got to solve for x. I got to solve for x. I just heard a y. That's all I heard. What do we do? What's my first step? Just basic algebra. What's my first step? Subtract a 3. Thank you. Subtract a 3. So I get y minus 3 equals negative 1/2 times the absolute value of x. What's my next step?
Any cheerleaders have ordered a picture, please come to the office to pick it up. Thank you.
You could divide it, but what's a better way than dividing a fraction?
Multiply by 2.
Yeah, well, negative 2, right. Multiplied by the reciprocal, right? Or the what? What's the word of the day? The inverse, okay? So what? So I'm going to multiply by 2 over 1. That cancels it out, doesn't it? So what do I do over here? Well, not 2, a negative 2. All right? So let's just switch the x's. I'm going to put this, so that canceled. I'm just going to put this on the left-hand side. Everybody okay with doing that? What do we get? Negative 2y what? Is it? How about plus 6? Okay. Now, do you remember how to solve for absolute values? We write it in 2 parts. Okay, we write the original one without the absolute value, so x equals negative 2y plus 6. And then the second part of this, how do we write it? We take the negative of this. All right, so it's going to be, x equals the negative of negative 2y plus 6. I'm not going to go through the background on why that's true, but we've talked about that before. No, stay right there. Is it really? Well, you better go then. So what's this going to be? This is going to be, just go. What's this going to be? 2y what? Minus 6. So I actually got 2 things. But is this an equation of a line, though? No. How do I write it? What was my second step? Remember, I solve for x first, and then what do? Just switch the x's and y's. So what do I get here? Y equals negative 2x plus 6. And what's this going to be? Y equals 2 what? X minus 6. So look, this, does that look familiar to you at all? It should look familiar because where did we get those 2 things? Where did we get those 2 equations? We got them up here with that yellow line, with that inverse line. And it's exactly what we got down here, isn't it? Okay, but we got it algebraically here. How do we get it up here? We got it by graphically. Okay? What do you think of that? Man, I don't know if we have time to. By the way, look at the blue one. Let's mention this right now. Is the blue one a function? Is it a function? The blue one. Why? Passes the vertical line test. What about the yellow one? Does not pass the vertical line test. So is that a function? No, it's not. You know another way to see if an inverse is not a function? Let me say this. Hold on. Give me a sec. I'm checking my notes here. I didn't write it down on my note. Oh, yeah? No, I did. Give me a sec. Give me a sec.
With Zoe Hamilton and Hector Santiago come to the office, Peyton Wallison to the office, Dana White to the office.
Oh, goodness. So many announcements. All right, let's look at the blue one again.
Thank you.
What if I didn't know the yellow one, okay? Everybody look up here. Okay, what if I did not yet know the yellow one? So what if my function looked like this? Okay? What if my original function looked like this? I didn't do anything to find the inverse, haven't graphed it or anything, I don't know. But how can you tell if the inverse of this is a function or not? What kind of test would it have to pass? Well, the function itself is a function, right? Or this graph right here is a function. Why? Because it passes what? The vertical line test. You can put a vertical line anywhere and it passes it. How do you know that the inverse is not a function? You got a vertical line test. Got a horizontal line test. Very good. So check this out. So if I take that original one, does it pass a horizontal line test? No. So that means what? It means the function is, it means the original, or the inverse. That's what I meant to say. Thank you, Cam. The inverse is not a function. So if it does not pass the vertical line test, keep getting them mixed up. I'm screwing everything up. If it does, thanks, Cam. You should just come up here and teach, please, because my head is somewhere else. You're paying attention. That's okay. At least that's what I heard, so that's all that counts. All right, so if the original thing, the original function, okay, if it passes the horizontal line test, that means the inverse is a function. If it fails the horizontal line test, which this does, correct? It fails the horizontal line test, that means the inverse is what? Is not a function. Okay? You don't even have to look at the inverse. You can just tell by the original one, if it does not pass the horizontal line test, the inverse is not a function.
So if the original function passes the horizontal line test, the inverse is not a function.
You got it. That's exactly right. Very good. That was perfect. All right? You got it? So, for instance, here, let's do this. Let's just do a basic, let's go white. How much time do I got? 5 minutes. Okay. So, watch. Let's just do a y equals x squared graph. Everybody look up here. Ready? I'm not going to draw this perfectly, but yeah. It's supposed to be a little more curvy, but you get the idea. First of all, is this a function? Is this a function? Yes, it is a function. Why? Because it passes the vertical line test. Is the inverse of this thing a function? What'd you just tell me? You just said it. So look, does it pass the horizontal line test? So that means the inverse, listen, it means the inverse of this is what? Is not a function. Okay? What if you had one like this? This is what function? You remember? It's x cubed. You're right. It's an x cubed. Now listen to me. Listen. Is the x cubed a function? Everybody look up here. Come on, think. Yes, because it passes the vertical line test. Is the inverse of the cube function? Why? Because it does what? Look. Is the inverse of this a function? Why?
Because it passes the horizontal.
That's what I'm looking for. Because it passes the horizontal line test.
If it passes the horizontal line test, the inverse is a function.
That's right.
Oh, I think you said it was not.
No, I said if it did not pass. I said if it does not pass the horizontal line test, then the inverse is not a function. If it passes the horizontal line test, the inverse is a function. Okay? So what does the horizontal line test tell you? It tells you something about the inverse of it, right? So if it passes the horizontal line test, the inverse is a function. If it fails the horizontal line test, the inverse is not a function. Yes? Okay. If I had 10 more minutes, I could probably finish what I was wanting to finish today, but I just don't think I do. But I came really close. We actually have 2 examples to do tomorrow. Write this in your notes. Remind me to do example 2 and example 3. Example 2 and example 3. Okay? So that's what we're going to do tomorrow. And you're still doing, well, yeah, try to do all the homeworks as much as you can. There may be some stuff on example 2 and 3 that you're supposed to do for homework tonight. I don't have the book in front of me, so I'm not sure exactly what the problems are, but do as much as you possibly can. I will give you tomorrow to work on the second half after we teach example 2 and 3. All right? Actually, you know what? I got to teach more than that. But anyway. What's that, like 17 announcements this class period now? Gee whiz. All right. That's all I got.